There's a quiet revolution happening right now, maybe even inside your own home. And it's not just about slapping some solar panels on the roof. No, it's much bigger than that. It's about our houses themselves, our cars, our entire communities transforming from just being energy consumers into active, intelligent power plants. And believe me, it is changing literally everything about how our world gets its power. See, for about a century, our electric grid was a pretty simple one-way street. You had these giant power plants at one end, and they pushed electricity in one direction, to your home. Simple. But now, with things like solar and wind popping up everywhere, that sleepy one-way street has turned into a chaotic, multi-lane superhighway with energy flowing in every direction. And what does that create? You guessed it, a massive system-wide traffic jam. So this gridlock, this traffic jam, it's the central challenge of our modern energy world. The system we built for the 20th century is being pushed to its absolute limit, and it just was not designed for what's happening right now. I mean, the scale of this change is just staggering. The old grid was predictable, right? A handful of massive, centralized power plants pushed energy out to us. The new grid, it's the complete opposite. We're talking millions of decentralized sources, solar panels on homes, batteries in garages, EVs in driveways, all sending and receiving power at totally unpredictable times. This two-way flow is something the old infrastructure was never, ever meant to handle. All right, so who are all these new players on the field causing all this beautiful chaos? Well, they go by a pretty technical name, but the idea behind them is completely changing our energy landscape from the ground up. They're called Distributed Energy Resources, or DERs for short. It's a bit of a mouthful, I know, but the key thing to remember is that these are energy assets located right where the power is actually being used, often behind the meter at your home or at a local business. So we're not just talking about huge solar farms out in the desert. This is a whole new class of small, widespread energy assets. And you're already familiar with the most common ones. You've got rooftop solar panels, which act like these tiny little power generators scattered all across our neighborhoods. And then you have home batteries, which can actually store that solar power for later, acting like tiny energy reservoirs in our garages. But it goes way beyond just solar. Think about community wind turbines, or maybe even the battery in your electric vehicle. Seriously, when your EV is plugged in, it's not just charging. It becomes a battery on wheels, one that's capable of either drawing power or even sending it back to help the grid. All of these DERs, when you multiply them by the millions, become the new drivers on our energy superhighway. So, with millions of these new energy sources hitting the grid, how in the world do you prevent total gridlock? Well, you need a traffic control system. And in the energy world, that system is called a virtual power plant. Let's go back to that highway analogy for a second. If millions of new drivers suddenly hit the road with zero coordination, what would you have? Total chaos, right? A complete standstill. You'd need a way to see all the traffic and direct it efficiently. So, how do you do that for an electrical grid? The answer is the Virtual Power Plant, or VPP. Now, this isn't a physical building with smokestacks. It's a powerful cloud-based software platform that does something pretty amazing. It digitally bundles together thousands of individual resources, your solar panels, your neighbor's battery, a local company's EV fleet, and gets them to act like one single, massive, and reliable power plant. So here's basically how it works. First, the VPP aggregates or bundles together thousands of these little resources. Then, using a lot of AI and forecasting, it analyzes what the grid needs and predicts how much power all those resources can supply. Next, it optimizes. It intelligently figures out which devices to use and when. And finally, it acts, coordinating everything to work in perfect harmony as a single, predictable asset. It literally turns chaos into a symphony. Okay, but think about this for a second. For VPP to control thousands of different devices, made by dozens of different companies, they all need to speak the same language. This is where a universal communication standard becomes absolutely essential. And that standard is increasingly becoming something called IEEE 2030.5. As the California Public Utilities Commission points out, it's basically become the default protocol for this exact purpose. You can think of it like the fundamental language of the internet for the smart grid, a common tongue that lets every device talk to the main system. This client-server model is really the key. The utility's main system acts as the central server. And every single one of those devices, your solar inverter, your EV charger, your home battery, is a client. This universal language lets the utility send super precise signals to thousands, even millions of devices at once, telling them to store energy, maybe use a little less, or send power back to the grid. It's like the nervous system of the virtual power plant.
So let's recap. We've got the devices, the DERs, we have the VPPs to control them, and we have a universal language so they can all communicate. But that's still not quite enough. To manage a system this complex, with all these VPPs, market prices, and the physical grid all interacting at once, you need an even higher level of intelligence. You need a new brain for the entire grid.
Now, the old brain of the grid was a system called ADMS. It was designed back in the day to manage a few dozen large utility-owned power plants. It was fine for its time, but it just cannot scale for this new world. That's why we needed a new brain, the DERMS, or Distributed Energy Resource Management System. The key difference here is scope. A DERMS isn't built to manage dozens of things. It's built to manage millions of customer-owned assets, and do it all in real time.
Think of the DERMS as the master conductor of this whole orchestra. It's a system of systems that sees everything, all at once. It's watching the weather to predict how much solar is going to be generated. It's monitoring market prices to make the most economic decisions. And it's coordinating with all those VPPs to balance supply and demand second by second. It's the ultimate intelligence, keeping our energy superhighway from crashing.
So what does all this complex tech, the DERs, the VPPs, the DRMS, what does it actually mean for you? Well, it means your entire role in our energy system is fundamentally changing. Because look, this isn't just technology for technology's sake. The whole point is to build a grid that is smarter, cleaner, and way more resilient. Instead of relying on a few huge, fragile points of failure, we're creating a distributed, flexible network that can adapt and respond by harnessing the collective power of millions of our homes.
And this brings us to a whole new identity for you, the prosumer. It's a mashup of producer and consumer. You're no longer just a passive customer waiting for a bill at the end of the month. With solar panels, a home battery, or an EV, you are an active participant. You're generating, storing, and even selling energy. You are a key part of this new power plant.
What we're witnessing here is the very beginning of a truly democratized energy grid. And that leaves us with a really fascinating question to think about. As our homes, our cars, and our communities transform from just being passive consumers into active power producers, what incredible new possibilities will that unlock for our future?